Okay, so for the third problem, I have f of x equals x times x plus 1 times x minus 1 times x plus 2. So I'm going to expand just like I did the last problem so that I have a full equation expanded out. This is nice for getting our real zeros, but I want to be able to expand this. So I'm going to take x times x plus 1, which is x squared plus x. I'm going to take and multiply the next two binomials together by FOIL. X times x is x squared. The outside, positive 2x. The inside, negative x. And the last term, negative 2. Simplifying, I have x squared plus x times x squared plus x minus 2. Now I can multiply these horizontally or vertically. I'm going to multiply them vertically. X times negative 2 is negative 2x. X times x is x squared. X times x squared is x to the third. X squared times negative 2 is negative 2x squared. X squared times x is positive x cubed. And x squared times x squared is x to the fourth. So I'm getting x to the fourth plus 2 x to the third minus 1 or minus x squared minus 2x. All right, so let me just write this one down. All right, so the end behavior. We have a degree 4, so n again is even. The leading coefficient of x squared is 1, so we're getting an end behavior again where it rises to the right and left. The real zeros set each one of these factors equal to 0, and there are 4. X is a factor, so setting x equal to 0 gives you 1 real zero. X plus 1 gives you negative 1. X minus 1 gives you positive 1. And x plus 2 gives you negative 2. The y-intercept, where the graph crosses the y-axis, I let x equal 0. So the y-intercept is 0. Now I want to determine the signs. I know the end behavior is that it's going to rise to the right and left, so I know that they're both positive, and I don't need to check those regions. So I know it's going to rise on both ends. So what's it happening in between? So I'm going to pick some values in here. I'm going to pick x is equal to negative 3/2. Negative 3/2. Negative 3/2 for x. Negative 3/2 plus 1 is negative. A negative 3/2 and negative 1 is negative. And a negative 3/2 plus 2 is positive. Negative times negative is positive, times a negative times a positive is going to make this region here negative. Next, I'm going to check in the region between negative 1 and 0. I'm going to pick negative 1/2 in that region. negative 1/2 is itself negative. Negative 1/2 plus 1 is positive. Negative 1/2 and negative 1 is negative. And negative 1/2 plus 2 is positive. Negative times negative is a positive times positive times positive is going to give you positive in that region. And I'm going to check positive 1/2 in the region between 0 and 1. Putting in 1/2 for x, that's positive. 1/2 plus 1 is positive. 1/2 minus 1 is negative. And 1/2 plus 2 is positive. So if I multiply these together, I'm getting a negative in this region. So I know what's happening between these values. And I'm just sketching this. I know that it's going to come below the x-axis between -2 and -1. It's going to go above the x-axis between -1 and 0. And it's going to go below the x-axis between 0 and 1. And again, this is just a sketch of the graph. If I wanted to be more specific, I'd use the intermediate value theorem and go between each of these zeros and find a value which is the turning point. And because it had a degree 4, I can have at most 3 turning points, which I have. It's a smooth, continuous curve.